Hey everyone, welcome to the latest episode of Rooted Digging In. My name is Nate Carney. I'm the Senior Equipment Support Specialist and Key Accounts Manager for Horticulture. And today's topic, we're going to dive into calibration, mainly focusing on the calibration of your soil mix lines. So one of the things we're definitely not going to dive into is specific controls. If you have some questions about specific controls on your soil system, it would be a good practice to reach out to your systems provider. So today we're just going to kind of give you an overview of the processes that we do and the pieces we look at to get our HydraFiber customers going. So three main reasons why calibration is a high point and should be one of the highest pieces that you look at. First is quality control. Now, if you're bringing in a pre-mix from a third-party supplier, there's going to be a very high level of quality control, and you're going to expect to get the same mix load after load. And it's only relevant to have that in your own processes as well. So if you're making your own soil, you should have the highest level of quality control because you're selecting those raw materials for a specific purpose. The second topic, and maybe just as important as the first one, is the substrate cost. You know, if you're planning on making a 70% 70-30 mix, and 70% of that is your higher cost component, but when you go into Calibrate, that's actually 80% of your mix. Well, that's going to drive your per cubic foot or per yard cost up, and not exactly what you had budgeted for. And then the third reason is to prevent downstream growth issues. So you want to make sure if you want to put in 6 pounds worth of lime or 8 pounds worth of lime, you're getting that exact number. So, you know, in 4 to 6 weeks, you don't have your grower coming to you and having downstream plant quality issues that could have been avoided. So the second big question is, you know, how often should we calibrate? Well, like anything else, more is better. But in a busy production schedule, you know, that's definitely not possible. So one of the things that we try to recommend is 2 times a year. So after you finish your busy season or you get ready for your next planting, it's a good time to just give your system a run through and just see where you're at and getting off on the right foot when you start your season. All right, so 4 key steps in soil system calibration. So the first key step is obtaining a baseline. So we want to look at exactly what you're putting in and where everything nets out from the beginning, so we know what needs to be adjusted and what can stay the same. The second piece is we're going to measure and adjust our individual raw materials. So if you're making a peat and HydraFiber mix, for example, well, we want to look at each one of those raw materials to make sure you're putting the exact percentage. Same way if you're using 2 other raw materials, you want to make sure those are exactly where you need it to be. The third step we're going to look at is measuring and adjusting your amendments. Like I had mentioned earlier, if you're wanting to put 6 pounds of dolomitic lime, you want to make sure you're in a reasonable percentage of that 6 pounds. And the fourth step we'll get into is kind of a fun one when, you know, all the work is done and we get to look at, you know, how we can grow our happy plants. All right, so a few just pieces of material we're going to need. So outside of your soil system and your soil system controls, you're going to need a large vessel or a bulk collection device. You know, a 1-yard box works very well, but if you have something that's a little bit bigger or a little bit smaller, depending on your soil system, that'll work perfect. You're going to need a cubic foot box. You'll need a 18-inch ruler or piece of 2x4, something rigid with a straight edge to to clean our cubic foot box on top. A clean work area, preferably concrete, is preferred for this activity. It's not really good to get gravel in your mix, especially if you're going to be repurposing that mix at a later date. And then a shovel and a broom to clean up afterwards. Some of the optional pieces we're going to need. So this is really if you're going to dive in a little bit deeper. So a 1/2 inch wire screen. If you want to look at screening different materials and looking at if you have any oversized particles or anything like that. An empty hopper, that's really if you're going to be repurposing the mix that we run, because we're going to run, 1 to 2, possibly 3 yards worth of material. So if that's real critical, then you want to be able to reprocess that. And then the last piece is a scale. Every material, every raw material has a specific bulk density. And if you really want to dive in to that particular piece, you're going to need a scale to make sure you're definitely hitting your bulk densities. So jumping right into here to step 1. So we want to obtain a baseline of our current mix. So the way your soil system is set up right now, that's the way we want to run it. So you're going to go over to your control panel, however it's set up, and whatever company you have, and you're going to run a 1 yard call. And if you're running a system that's running at a lower rate per hour, that's 100% fine. If you want to make a 1/2 yard call, or if your typical test is 10 cubic feet, all of this is going to line out to whatever volume you typically run. So first, we're going to make that 1 yard call. We're going to collect it into our vessel. And one of the things that you may note, and this image in the middle really kind of highlights that. And it'll depend on what raw material you're running, to where if you make a 1 yard call, if it's going to fill up your box. You could be exactly 27 cubic feet, and because of settling, or if you had to move the forklift, you could see that headspace at the top, and that's 100% okay. So after we run our material, we're going to want to empty those contents on the ground. So we just make a giant pile, and from there we'll kind of work with our cubic foot box. So we tend to use a cubic foot box for all of our calibrations, and this is something that a lot of people in the industry use, and something that we have distributed and will continue to distribute to our HydraFiber customers, because it's more accurate. As you saw in the previous picture, with different raw materials, you can get a settle in a 1 yard box or any large vessel. So we try to look at everything through a cubic foot box, and what we call, cubing it out. So we're going to take that yard, we'll place our cubic foot box next to the pile, and then the next steps are as easy as, taking your shovel, flipping your pile and your raw material, and, in a careful fashion, adding that material to your cubic foot box. You're going to want to leave about 1 inch to 2 inches above the vessel, and then that's when you'll take your straight edge and level over the top. Once you level over the top, it's good practice to take those cubic foot boxes and stack them out in individual locations. One, this is good for you at the end to come back and look, because there's not a good feeling when you get to 26 or 27 and you're dumping back into your vessel and you completely forget what you're doing. So it's good to lay those out and look at how many you have at the end. So, if we're targeting to make a 27 cubic foot call, and you're between 25, 26, and say 28 cubic feet, you're within a reasonable plus or minus variance. But there have also been instances that I've seen where, I've gone in and made a a calibration at a customer's location, and we came back, with 32 cubic feet. Well, again, to the second point on cost of the material, well, their costs are going to be all out of whack because what they had thought they were making at the end of the day, they were nowhere close to it. So this is why this makes for a good practice. All right, so once we have measured our our total substrate blend, we want to go in and look at our individual raw materials. So a very, very similar process to how we did with the complete substrate blend. But in this case, we're gonna run on manual. And what we want to do is, if you're doing, let's just say for an example, a peat and HydraFiber mix, you're going to want to cut that second raw material off. And what we'll do is running it in manual is one of the easier ways to do that. But again, if your control system is set up to allow you to set one raw material to 0 and one on the other target percentage that you're looking for, that works just as well. So we're going to make that 1 yard call, and we're going to follow the exact same procedure as we did for our baseline. We're going to collect everything in our large vessel. We'll empty the contents out on the ground, and then we'll cube it out from there. Now, as an example, if we're targeting a 60% peat mix, then you're going to shoot for about 16.2 cubic feet of that individual raw material. Now, if you finish your measurements and you're at 14 cubic feet or 18 cubic feet, I think you're going to need to take a second step there and look at how your material is metering out, and follow the procedure laid out by your controls provider to make that adjustment, whether that's changing the speed on the conveyor or changing the speed on, or changing the height on the gate. And that way you can get back down to your 16 or whatever your target would be. So one of the raw materials that I had mentioned makes it a little bit more difficult to measure in that way. And that's measuring the amount of HydraFiber in the mix. So if we went off of the example we just gave of a 60% peat, 40% HydraFiber mix, well, because of the light bulk density and the characteristics of the HydraFiber, it makes it tough just to run the raw material out on the ground, dump it into individual cubic foot boxes, and then cube it out from there. So one of the methods that we've come up with is measuring the in-feed speed on the HydraFiber processing unit. So the way the equipment is designed is there's a fixed box at the top. So anything that feeds into that box goes into your mix. There is nowhere else for it to go. So that's why it makes this method effective for measuring that. So on all of the machines, right by the tail pulley, you can make 1, 2, 3, and 4 inch marks. And what we're going to do is we're going to start our in-feed at our given percentage. So going off of the example we used earlier for 40%. So we're going to start our in-feed, begin feeding our HydraFiber, and we're going to time the amount of seconds it takes for that in-feed conveyor to travel 1 inch. Okay. Now, I'd recommend using a lap feature, or doing this 3 or 4 times to really get an average, because again, like anything we're doing, it's not 100% every time. So you want to make sure you're getting an average. So now, once you have your amount of inches per second or seconds per inch, then we can run through a series of calculations, which I've put up on the screen, to kind of go through and determine the actual percentage we're putting in and the number of cubic feet we're putting in. So going off of the example earlier, so in this particular case, it took us 6.33 seconds for that conveyor to travel 1 inch. So what we're going to do is we're going to figure out what that multiplier is. So 60 seconds divided by 6.33 seconds per inch gives us a multiplier of 9.41. So we're going to take that and come down to step 2 and multiply that by 1.92 pounds. So what we're looking at here is determining the number of pounds of HydraFiber per minute. And I use 1.92 because our standard size bales are 22 inches long. So per 1 inch is 1.92 pounds on an average. So keeping with that same example and taking our multiplier by 1.92, we come back with 18.18 pounds of HydraFiber per inch, or per minute, excuse me. Now, we work in volume. That really makes no difference. So what we're going to do is we're going to take that volume and that weight, and we're going to turn it into volume. So step 3 is where we're going to divide by our density. So our density can be set out in 4 different ways, and these figures are worked off of averages and multiple situations that we have looked at in the past and through 60 different HydraFiber processing units. So if you're making a lightweight or a peat mix, so if you're doing a 60% peat, 40% HydraFiber mix, your HydraFiber is going to have a 1.7 pound per cubic foot density, or a yield of 29.42 cubic feet per bale. Now, if you're using a heavier raw material like bark or coir or something else, that yield is going to go down because there's going to be extra shrink with the 2 materials combining together. So if you're up to 40%, that density of the HydraFiber is going to go up to 1.93 pounds per cubic foot, or a yield of 25.91 cubic feet. The goal in both of these situations is to make sure when you're putting 60% peat or 60% bark or coir and 40% HydraFiber into a mix, that at the end of the day, you get 1 cubic yard at the end. And that's why we have different figures here. So let's use the example with peat. So we're going to take our 18.18 pounds per minute of HydraFiber, and we're going to divide that by the 1.7 pounds per cubic foot, giving us an open cubic footage of HydraFiber of 10.89 cubic feet per minute. So now we got something that we can work with. Then the next piece here is to take that and divide it into a 1 cubic yard. So step 4 is in our 60 yard per hour system at 10.89 cubic feet of HydraFiber. That puts us right at 40%, which is our target. All right, so now that we've measured both of our raw materials and made adjustments wherever we need to, now it's time to move on to our amendment package. And this can be even more critical than your raw materials, but also they work hand in hand, because you pick these and you have certain rates on your amendments to offset and to go with what raw materials you're using. So this step is probably one of the most simple steps out there. So you're going to turn your system into manual and run your hopper just by itself. You're going to put a bucket, a collection device, as you see in the image, we've got just a large Ziploc bag that's going to collect all of the amendment that's falling out from there. And from there, it's as simple as weighing the contents and determining where you stand. So if we look at the example below, if we collected 3.5 pounds of dolomitic lime in 30 seconds in a 60 yard per hour system, we're going to take that 3.5 pounds, multiply it by 2, and that'll give us our weight per yard. So if we're targeting 7 pounds per yard, we're dead on where we need to be. But if we're targeting 10 pounds per yard, then we may have some issue downstream, and that's where you're going to need to adjust your bin and the output thereof. So that could either be adjusting the gate again, or adjusting the belt speed, whatever is laid out again with your control system. So the fourth step, and probably the piece that reaps all the benefit of the hard work that you just did in your soil and production barn, is growing happy plants. You know, if you hit your amendment numbers, you hit your raw material numbers, then your growers are going to have a lot easier time, and they're going to know exactly what they're given. And like this particular HydraFiber customer in 60% peat, 40% HydraFiber, you're going to have bay after bay after bay full of beautiful plants that the stores and the customers are going to love. I hope this kind of gave you a good overview of how to calibrate your soil system. If you have any questions, feel free to reach out to your HydraFiber technical account manager for assistance. We've got a number of calibration tech sheets and pieces of information that we'd like to share. So if you have any questions, feel free to reach out to us, and we'll talk to you next time.